My name is Moses Hernandez, and this is my math final for Math 115. I'm going to be talking about chess, wonders and beauty, the intersection between chess, art, and beauty. Side note, I will be looking down. These are my speaker notes. And second side note is this video would be best understood with a basic understanding of chess, and probably if you flipped over my essay. But don't worry, I've watered it down just a little bit so it can be beginner friendly and everyone can get some takeaways. So in my video today, I'm going to be going over three things before I share my screen and do kind of a little practice session with an actual chessboard. First, I'm going to talk about how chess just acts like conceptually in relation to like scientists and philosophy and just like other adjacent games like checkers. I'm also then going to be telling you about computers and how those have been used to try and better understand chess. And then thirdly, I'm going to tell you solvency, how this relates to the idea of solving chess as a game. And when I share my screen, doing a chess lesson, it's going to be furthering the points that I've explained so far, but we'll get there when it comes. So first, I'm going to tell you that chess is conceptually large. It's a very hard to grapple game, even just with 32 pieces and 64 squares. The amount of unique positions that can occur is 10 to the power of 120. And to best understand this as we can, it is the number one with 120 individual zeros at the end. That's how many different positions there are. And so even though each piece has like a finite amount of moves similar to checkers, it should in theory be able to solve, should be able to be solved, but has not yet. Checkers, very similar game. They have used computers to solve it, which when I say solve, means that a computer can output the moves to at best get a draw when facing another computer that can solve it, but at best do a win when facing another human that's imperfect. To get into my second point, talking more about computers. Computers, as soon as they've been invented, have tried to solve chess because it's been around for centuries. Humans have not been able to master it. Humans have tried to relate it to other aspects of life, like, oh, if you're good at chess, you're good at strategy. If you're good at chess, you're good at manipulation. If you're good at chess, you have good IQ. Humans have tried to have computers master it, and they have not done that yet. We have seen, though, computers beat every grandmaster and woman grandmaster out there. Thanks to when computers beat Bobby Fischer, they beat Gary Kasparov, they will always beat grandmasters. This does not mean that it has been solved. Why? We can have two different computers of the same engine or one computer versus a different engine have win-loss games consistently, which should not be possible if they are playing optimal moves, because that means it should come to a draw. What this kind of alludes to is that these computers are making excellent moves, but are very on a small level inaccuracies. They're not necessarily mistakes because they're bad. It is just not the greatest move out of all, the hundreds and thousands of millions of options out there, even, more than millions. Like I can't even say because I don't know what's greater than like billions and trillions and zillions. What this shows is that computers can't grasp with, positions that are like 1 to 120 individual zeros. They have not been able to solve that. What I'm also going to talk about is that even if they can solve chess, it's not going to necessarily be applicable. I've showed you first like the beauty and like the concept and how it's just so large, but I'm also going to tell you that even if it could be solved, humans are naturally inclined in the game of chess to not use that information. Why is that? I'm going to talk about openings and opening theory. If you don't really know what this looks like, this is when the chess game begins, the opening refers to the first like 8 or 12 moves, where because you are a chess player, you should know the best beginning moves out there. Like e4 was then responded to sometimes by d5, and then you would respond by d4, etc. We know this because we have chess books and chess engines that tell us the best moves. And if we assume that those players know the best moves, they should be able to study whatnot to get to like that middle game position. What I tell you is that a lot of players have this strategy where you concede positional value for knowledge. What does this look like? If someone were to play e4, they probably know a lot of the lines and the sharp tactics that were to continue if black responds with the best possible move. What conceding the position looks like is maybe responding with a move that's going to lose you value, maybe something like a3. But what this does is you've studied a3, and even though you're in a worse position, you have more knowledge. Your opponent might not know what this position looks like and studied the lines and tactics because it is just atypical and just positionally bad. If we still imagine like computers being able to solve a chess game, we can still have this be a reoccurring thing, like this beauty of like an intentional fatal move for oneself to end up winning in the end because of just like this idea of memory. If there are so many moves, it's going to be impossible to memorize all the beginning moves. And even just if you don't buy that, there's still the element of like wanting to be entertained and not wanting to be machines. And just this idea has already stood with computers existing in the status quo that can beat grandmasters. We're still resulting to individual self-sacrificing moves to come on top of our opponents. And I just think that's really interesting to the human spirit. So I've proved that solvency won't change your game. But I'm going to now share my screen into a little bit of a demo on a chess game with only three pieces to kind of show the complexity for even humans and how just with three out of the 32 pieces, it might be too hard of a game to even comprehend, but still like incredibly interesting and dynamic and just proving the points I've shared so far. So let me share my screen. And so here we have the king pawn endgame. Two kings would by themselves end the game in a draw. With the pawn, the goal is for white's pawn to get to the top rank, promote into a queen, and from there white can do checkmate, which is a win. Black's goal is to force a draw, which would be considered good for black since black starts at a small disadvantage from going second. But in this game, black has two choices going to d6 and e6 are, the moves that we'll look at. D6 forces a draw, and, just moving one square over to E6 forces a win for white if white knows what they're doing. So let's just look at this. If the black goes E6, white will go up, and this is going to refer to a position or just an idea called Zutzing, which is where we have a symmetrical position and the person who breaks the symmetrical position is often going to come out losing. So black can either go left or right, or towards the top rank, which would just let white pass their pawn further. So we're going to end up choosing going right. White will go up to protect the three squares for that pawn when they so choose to move it. And black has been faced with a very difficult decision. If white goes Sorry, if black goes king f5, which is down, which would be, looking like they're attacking the pawn, this would actually be a loss because white can move their pawn two squares up, black's forced to retreat, white can protect three more squares, black can't go down, and going right would lose, so they go up, and then white just pushes their pawn to the symmetrical position, saying black's forced to break the symmetricness, and white protects those three squares and promotes to a king. The other move for black is going to king e7, which again, white can force the symmetry. And we see black having to move. White then protects three more squares, and white can finally move the pawn. Even though white is forced, like in the symmetrical position, to maybe break symmetry, they can continue the symmetry, having white end up breaking it having black end up breaking it here. Black has to move. White can protect the next three squares, which is very key. And white then is allowed to promote a queen, and this would be a win for white. If you look to the left, there's lots of different pawn endgames that I have. This is just my WeChess account. It's just incredibly more complex than even what I'm showing you. But the idea here was to show the conceptually large aspect of just a three-piece game. I've showed you that even with computers, like this computer like lines, It's still very hard for a human to grasp, and we don't think that people would just know like the best computer lines. And I've also told you that even though the game from this point and from the beginning could be solved by computers, that doesn't necessarily take away from any of the beauty or art or math from this chess game. So, just in conclusion, what I've tried to bring to you today is the understanding that in the end, chess remains a celebration of math, not because it can be solved, but because it hasn't, and with the advocacy of some of the best players never will ever have to be. It is the elegance that ties chess to the value of human hearts, and chess stands as the perfect intersection between beauty and the endless striving of the human spirit. Thanks for listening to my presentation, and everyone, good luck with your finals. Have a good rest of your day. Bye.